First of all, thank you for having me. Sorry about the technical difficulties. Today I'm going to be talking about choice, welfare, and market design, where I'm going to be investigating the allocation of food to food banks from an empirical market design perspective. Next. Many organizations are faced with the problem of allocating scarce, heterogeneous objects that arrive stochastically. Councils have to allocate houses among public housing among tenants. Hospital boards have to allocate kidneys among transplant patients. And a fundamental question is just how much choice should agents have? To what extent should agents be able to signal and act on their preferences in this environment? Next. So we know that the benefits of allowing agents to choose depends on the degree of heterogeneity in preferences and also the substitutability of objects. So for a given unit of public housing, if every agent has the same value of that unit, then it won't matter for welfare which agent we give that unit to. But if the agents all vary a lot in their values for that house, then it will matter much more. And so in order to empirically investigate the benefits of allowing agents to choose, it's going to be important that we're able to accurately estimate the degree of heterogeneity across agents, the degree of substitutability of objects, and so just be able to accurately estimate agents' preferences. Next. In this talk, I'm going to discuss the allocation of food to food banks. So food rescue organizations are charities that receive truckloads of food every day and have to decide which of their network of food banks to send this food to. And this is a problem faced by many organizations around the world. I'm going to focus on Feeding America, the largest food rescue organization in the United States. Next. So food banks have become an integral part of US society, with actually 1 in 7 Americans making regular use of a Feeding America affiliated food bank. Feeding America is directly responsible for allocating around 100,000 tons of food every year. And so the efficient and equitable allocation of food is a key priority for Feeding America. Next. Before 2005, food banks were essentially just offered food at random, and this was extremely unpopular because different food banks want different types of food from Feeding America, going back to this point of heterogeneity. So a food bank in rural Tennessee that's surrounded by a number of farms is likely to have a weaker preference for fresh fruit and veg than a food bank in central Manhattan. And this is because, as well as receiving food from Feeding America, food banks also receive food from local donors, so local farms, local grocery shops. And importantly, what a food bank actually wants from Feeding America is likely to change over time after a bad harvest, or if they just haven't received breakfast cereal from their donors in a while, and their local donors in a while. Next. So in 2005, working with a team of economists at the University of Chicago, and in order to give food banks a degree of choice over the food that they received, Feeding America introduced an auction system. So in this system, food banks place bids using fake money in a series of first price auctions. I'm going to talk in more detail about the system later on. But the key point is that this system was very popular, at least relative to the previous system. Next. So what I do in this project is I investigate how does welfare compare under these two regimes. I then, I push deeper into this question, asking, okay, what are the factors that drive this difference? Where are these benefits of choice actually coming from? And in the paper that I won't discuss today, I also look into whether other food bank networks could benefit from adopting a similar system by thinking about some of the mechanisms that are used by other food bank networks. For example, just sending food to the nearest food bank. Next. So these food banks, we're talking about large warehouses stacked to the brim with various types of food on pallets. Next. And these food banks have fleets of trucks at their disposal to send all across the country, picking up and dropping off food as it's needed. Next. They work with around 200 food banks across the country, providing food to feed around 130,000 people each day, and all different types of food gets allocated. Next. the way that the system works is that Feeding America will receive a donation of cornflakes, and they have to decide which of their food banks to send this food to. These food banks then send this food on to food pantries, local churches and community centres that then directly distribute this food in the community. They also receive food from these local donors, local farms, and grocery shops. In this project, I focus on Feeding America distributing food among food banks because that's what I have data on, but I also take into account that what food banks want from Feeding America will be determined by their stocks, which will be determined by their local donations and the food they send to food pantries. I don't observe food bank stocks, so this is going to be a key challenge for me to get over. Next. So what I want to do is estimate food banks' demand functions and then use these to run a series of counterfactual simulations comparing allocations under these regimes. Next. There are a number of challenges to this. So I have dynamics. Food banks are making dynamic decisions. Do I consume cornflakes today or wait until maybe consuming granola in future? Food banks also bid strategically, so I don't observe their demands directly. I only observe their bids. And finally, I don't observe food banks' stocks. And it's really the confluence of all three of these challenges that is actually a problem. And I get around this by I'm going to estimate a structural dynamic auction model allowing for this unobserved state, these unobserved stocks. Next. I'm not going to talk too much about like contribution and stuff in the interest of time. The main thing to say is that I'm building on some previous work by Canis Prendergast, one of the designers of this auction system. And I'm complementing Canis's work using structural model to push deeper into some of these questions about welfare. I'm also building on some previous work on my own. I have a working paper looking at an empirical model of dynamic multi-object auctions, and I'm going to use some of that. I won't talk much more about that next. Next. Don't know why I kept the outline slide. So the way this auction system works is that every load is put to auction in simultaneous first price format with around 30 auctions happening simultaneously each day. Food banks place bids using this fake money. All the fake money that gets spent gets reallocated at the end of the day. How much of this fake money a food bank receives depends on the poverty in their area, and fake money can be saved and borrowed. They can place negative bids down to a reservation price, which is just going to help shift undesirable loads to keep the donors happy. Finally, the supply of this fake money varies with the supply of food to keep prices constant, so that food banks always know roughly how much they should bid. Next. I'm working with standard auction data. I've got 4 years worth of data. I've got data on my food banks, but I don't have data on stocks. And so this is going to be a key challenge that's going to come up repeatedly in this talk. Next. So now I'm going to tell you a bit about my model. Next. I'm going to build an empirical model that needs to incorporate 4 key facts. So I see systematic differences in bidding behavior, both across food banks, across different types of food, and across time. So I'm going to need a model that's able to capture these different types of heterogeneity, in particular this sort of time-varying unobserved heterogeneity that I'm going to attribute to these unobserved stocks. Second, I have dynamics. I see a food bank win a load of cornflakes and then stop bidding on cornflakes. 3, I also have my food bank solving actually quite a complex combinatorial problem. There are 30 lots to bid on. Which subset of lots is the food bank going to bid on? And so I'm going to use a multi-object framework that will allow me to capture these the trade-offs, the decisions that food banks are making here. And then finally, I have negative prices and infrequent bidding. So if a food bank doesn't place a bid when they're allowed to bid negative, that tells me they have a negative value for that lot. This tells me there's some cost associated with accepting food, transportation costs, but also storage costs, which are going to be key in my model. Next. So food banks are going to place bids. which are going to be a function of their beliefs about how aggressively other players will be bidding, and also a function of their payoffs. The exact form of this bidding function is going to depend on the strategic environment. So I'm going to assume conditionally independent private values with risk neutral and patient bidders. Standard in empirical auction studies, I'm going to assume quasi-linear payoffs. Next. So a key question is, okay, where do these payoffs come from? Well, the food bank's payoffs are going to depend on their stocks. They're going to depend on stocks through this flow payoff function J, which is going to capture the utility to a food bank from holding food to give out to food pantries, and also the storage costs of actually holding that food. I'm going to focus on, in stocks, I'm going to focus on the way that the food is actually stored. So whether the food is dried, which tends to be quite light but bulky, whether the food is tinned or bottled, so like heavy and dense, if it needs to be refrigerated, or if it's fresh and liable to spoil. Next, like I said, this is a dynamic model, so influencing how aggressively a food bank bids is also going to be their continuation value, V, which is going to take into account that a food bank knows, okay, if I win cornflakes today, I won't have room in my stores to win granola tomorrow. And I also introduced this lot-specific idiosyncratic term, U, which is going to capture transportation costs, and broadly, it's just going to be like my regression residual. Next. Now, as I said, I don't observe stocks, so I'm going to assume a stock process. Each day, your stocks depend on your stocks from yesterday, ST-1, your winnings from yesterday, and also this random variable X, which is just going to be your local donations minus the food that you distributed to food pantries. I'm going to assume that X is exogenous, so food banks take as given what food they receive from local donors and what food pantries come and take from them. Next. So a key question here is, are the modeled primitives, the flow payoff function J, the distribution of net donations F, are these uniquely pinned down by my bidding data? Identification is a challenge for a number of reasons. I'm going to focus on this these unobserved stocks today. So we know that identification can be a challenge when you have time-varying unobserved heterogeneity, whether you can actually identify that unobserved heterogeneity. Now, my model remains identified through two sources of variation. I can use variation in the size and composition of lots that are auctioned to pin down this function J, in particular to pin down my, my storage costs. I look to see how a food bank bids when there's one load of cornflakes available. They always place a bid. I then look to see how they bid when there are 10 loads of cornflakes available. But I see that they still only place one bid. This tells me that they don't want to win too many loads of cornflakes because perhaps they can't afford to store too many loads of cornflakes. So this just pins down my storage costs. I then use observed variation in my winnings to pin down the distribution of net donations. So I see, okay, a food bank wins a load of cornflakes and they stop bidding on cornflakes because they don't have room to store cornflakes the next day. I see that on average, it takes around 4 days before they return to bidding on cornflakes again. That tells me that on average, it takes 4 days for them to give out that load of cornflakes. And this just pins down the mean of these net donations. And I can use variation in this return time to pin down the remainder of the distribution. Next. So to estimate this, I use a 3-step estimation procedure. In the first estimation step, I estimate the distribution of food banks' beliefs, so the probability that food bank I wins lot L given their bid. And this is standard in empirical auction studies. Then in the second step, I estimate the distribution of net donations, as well as this function K, which is a sum of the flow payoff function and the discounted continuation value. This, I refer to this function as the pseudo-static payoff function. It's essentially what you would estimate if you incorrectly estimated a static model, assuming that food banks were myopic. And I do this because at the third step, it turns out that I can write the continuation value as a function of my observed bids and the estimated function k. To those of you that are familiar with conditional choice probability estimation, this is very similar to how we might write the continuation value as a function of estimated conditional choice probabilities. So the main problem then is, okay, how do we estimate this function k that's a function of stocks when we don't observe stocks? And I do this by, I use a Bayesian estimation method, I use a Gibbs sampler, and I broadly just iterate back and forth between two steps. And these two steps just correspond to the two stages of the identification framework that I presented previously. So in the K step, I pin down K using seeing how bids vary with with the size and composition of lots on offer. Then in the second step, in this S step, I pin down the distribution of net donations by seeing how bidding behavior varies with winnings and using this to back out changes in stocks. So I see that they win a load of cornflakes, their stocks increase by one load of cornflakes, and they stop bidding on cornflakes. 4 days later, they start bidding on cornflakes again. This tells me that they have, in that time, given out that load of cornflakes. Their stocks of cornflakes have decreased back to their original level. Next. So I'm now just going to present a few results. So here we have the mean of these net donations. On average, these are negative, which tells me that food banks give out more food than they receive from their local donors. And the key takeaway here is just we have a large degree of systematic heterogeneity, both across food banks and within food banks across different types of food. Next. Likewise, here we have the estimated marginal flow payoff function. This is negative, so on average it costs food banks to hold food, just evidence of storage costs. Again, heterogeneity both across food banks and within food banks across different types of food. Next. Next. So now I'm going to talk a little bit about my counterfactuals. I'm going to consider 3 counterfactuals. So the auction system, the old system where food was more or less offered at random, you get to the head of the queue and what food is offered to you is essentially random, and also just a random allocation that I'm going to use as a benchmark. For each of these mechanisms, I numerically solve for the Markov perfect equilibrium, and then I'm going to consider welfare in terms of consumer surplus, which is measured in this virtual currency. And I can interpret this consumer surplus in terms of like an equivalent increase in the supply of food, because I know that if the supply of food was to double, the money supply would adjust so that prices remain constant and expenditure doubles. So if going from the old system to the auction system leads to a doubling in consumer surplus, I can interpret this like the supply of food doubling. Next. And so here are my main results. In red, we have the posterior distribution of welfare under the auction system, and we can see that it's significantly higher than welfare under the old system, to an amount of around 140 tons of food per day, which should be viewed relative to the 300 tons of food that are actually allocated each day. But importantly, both welfare under the old system and under the auction system are much higher than under a purely random allocation, which basically just says that the benefit of giving food banks even a little bit of choice is extremely high. Next. So finally, I'm going to think a little bit about where this benefit's coming from. I'm not going to talk about this in too much detail. So first of all, I see that more food is allocated under the auction system. This is due to these negative prices, just incentivizing food banks to take more food. I also see that less distance is traveled under the auction system. So food banks are sorting into consuming closer food. Finally, I don't actually see a difference in storage costs under the two mechanisms. But this is interesting given that under the auction system, food banks are actually storing more food. So what I'm seeing is this food is just being stored more efficiently. So then I push into this a bit deeper and I see what's happening is that food banks are sorting by the types of food that they are consuming. So, food banks in rural Tennessee who already have loads of onions aren't receiving any more onions from Feeding America. But also, I see that food banks are using choice to smooth their stocks over time. So what they're doing is they are substituting food that they perhaps didn't receive from their local donors with food from Feeding America. And so when we give them access to choice, they're able to do this more efficiently. And finally, on average, 90% of food banks get higher welfare under the auction system than under the old system. What's the line? Raising tide raises all ships. Next. And so I will leave it there. Thank you very much for coming. Any comments or questions you have, I would be very happy to answer. So yeah, thank you very much.
Hi there. Thanks for the talk. It was really interesting. One of the things that you mentioned really early on was that the new auction system involves allocating a specific number of units of this virtual currency to each of the different locations instead of just, splitting it equally. And it seems to me like that choice probably has a huge impact on welfare. How are the decisions made right now? And do they seem good, bad, or how do they play into the analysis that you have here?
No, now I'm unmuted. So the way that they do it is they just take into account how much poverty is in your area as well as how large the population is. I can't really speak hugely into how well this is done because in particular, what they don't do is they don't take into account how many local donors you have. And ideally, we would like to give more of this fake money to food banks that don't have many fake donors, don't have many local donors, and so have to rely on Feeding America for their staples. They chose not to do this. It was like a big sort of political decision that I think is a problem because what we see is food banks that have many local donors have a very low opportunity cost from spending this fake money. If I don't spend it today, there's not much that I'll want to spend it on tomorrow because I already get so much of my food from my local donors. And this means that these food banks perhaps push up prices, potentially causing some inequity. But this is where this is sort of the bleeding edge of this research project. Yeah. Any other questions?
Do you hear me? I don't know. Yeah. Do you see some types of food that you might take out of the bidding and?
Yeah. Fresh fruit and veg in particular. And actually, Feeding America.
Is there room for improvement by taking it out, by making the choice system simpler and just focusing on what you really need to bid on?
I think so. So Feeding America seems taken out fresh fruit and veg because essentially it was always going at the reservation price. So actually, for fresh fruit and veg, you couldn't bid negative. You could only bid down to zero, and just everyone was bidding zero. And this was just essentially leading to inefficiency because you would just have everyone bid zero, you'd have a tie, they would just then do it randomly, and they seem to realize that actually just allocating this food outside the system is better. This might have some, there are some positives to this because you no longer have this randomness, food banks not being sure what they're going to receive. One could even argue that maybe you could split up food into different types and auction it separately. Other food bank networks that don't use auction systems do something similar to this, distributing food by type of food. Whether this would lead to any benefit, I'm not sure. Like you can give food banks a budget for vegetables and a budget for meat, for example. I think it could introduce too much complexity, which is a major something that they think about a lot. Anything else?
We have one more question here.
Hey, thanks, Sam, for a great talk. I was wondering, so just to make sure I understand, the only heterogeneity in preferences across foods from food banks is due exclusively to stock differences. Is that correct, or at least consistent preference difference?
In reality, it's going to be everything. It's going to be different transportation costs, different stocks, different storage costs. In my model, I focus on, I'm estimating a separate model for each food bank, which means that I'm allowing for different storage costs, different transportation costs, and different stocks.
Got it. Great. Thanks so much.
Do we have time for one more question?
Okay. So I might have missed this in the model, but it seems that there's no budget constraints that, is that right, that the food banks are facing? If there are 30 auctions happening every day, I'm not bidding for the cornflakes, it might just be because, there's something else that I want to bid more. And also, how is this am I saving money for, what could be available tomorrow? Is there dynamics there as well?
Yeah, so this is a fantastic question. In the model, it's quasi-linear. I have this result in this other paper that quasi-linear model is observationally equivalent to a model with an intertemporal budget constraint, so long as the marginal value of spending a share, like the Lagrangian multiplier, is constant over time. To answer the second part of your question, when I see that they don't bid on all 10 loads of cornflakes, I can look to see how their bidding behavior across numbers, the different lots that are allocated simultaneously, how it varies depending on how substitutable the lots are. So for example, when I look at cornflakes, there are 10 loads of cornflakes available, they'll only bid on that one load of cornflakes. But when I have, one load of cornflakes available, a load of meat, a load of milk, and other snacks, 10 completely different things, I don't see them stop bidding on them all. They bid on all 10, which just suggests that it's not so much about the budget constraint. Another one is, after they win a load of cornflakes, they'll stop bidding on cornflakes, but they won't stop bidding on Slim Jims or jerky or something else, which just suggests it's probably not just about the budget constraint.
Okay, thank you very much.
Okay.
Thank you very much. This has been really great.